Genders and lady men. I'm Spiro, and I'm not a wizard. Today, I think we're doing episode 6 of our C64 basic tutorial. I've decided this time that I'm going to try and do a script, which is very unusual for me. So bear with. Hopefully I'll stick to it. The topics here we're going to be going over are conditionals. So GOTOs, GOSUBs, for statements, if statements, and on statements. So the easy one is GOTO. We all know the classic hello world in basic program, which is to print hello world and then 20 go to 10. We run that, it prints that forever. So the C64 basic, as we've learned, doesn't have the concept of labels. In some other basic dialects and in some other languages, you might have start colon and then go to start, but they're not features of this, and this version of basic only works with line numbers. So that simply means when you reach this line, go to the line I've told you to go to, which is line 10. That's our go-to statement. It's just simply when you get here, go there. A bit more fancy is a subroutine, so a GOSUB. So we can run our program new if we want. So this will go to a line, but when it reaches the return statement, it will return there. So it'll return to just after that point. So if we do, I'm going to do shortcuts here for print, and I've probably got retarded typing. It's been very cold here lately. It's middle of May, and I think we're starting our winter early. So I'm just going to do, before you can see this, maybe I'll make this available on my GitHub repo so you can go through it later. So if we go sub 100, we're going to go to a subroutine, and we're going to print after sub. We probably want to end the code there. So the thing is with a basic program, normally when we have a program, we'll write all our main, like our main loop or our main program, and then the subroutines will go later. But if we don't stop the program from executing, it'll just go on and try and execute those subroutines. And the first time it reaches a return, it'll be like, I don't know where to return to, and it'll throw a wobbly. But if there are a bunch of statements in that subroutine, it will have executed, or at least it will have tried to execute all of them. So what we want to do is we want to stop our program once we get to here. We're going to print a before sub, so to show that this is a print before we enter the subroutine. We're going to go to the subroutine, and then we're going to print something after we've come back from the subroutine. And our subroutine, as we can see, is on line 100. So we'll print during the sub. Alright, and what we need to do is we need to return. So that is a return from subroutine. In 6502 assembler, it is the same as the RTS statement. Maybe you knew that, I don't know. So if we run that now, we're going to get the line before the sub, because that executed before the subroutine was jumped to, during the sub, and then after sub. So it did those in order that we told it. So what happens is the return statement will return to the end of this GOSUB. So in fact, if I'm going to do a little bit of a, will that work? No. I'm just going to clear the screen here and list that. So let's do a print after sub here on this line, and then we will get rid of line 30. So you'll see logically the program is still exactly the same. The GOSUB, when it returns, it will go to the next statement, not necessarily the next line. Of course, unless that is the only statement on the line. So you'll see we're still getting the exact same thing. That makes sense. So yeah, that is GOSUB. Now, for statements allow us to create a little bit of a loop. So you'll have seen things like for I. Now I tends to get chosen. People do I. I've always think in my head I stands for iterator or iteration. Some people like doing C for count. 1 to 10. So we specify. Actually, that's something I didn't do in my script, which I just think of now. Step. We can do steps. We can go. We'll start with the basic for loop. So we'll do the count is 1 to 20, 1 to 10. We're going to print C, which is going to print the number that we're currently at, so we know. And 30 next. Now, another feature of C64 Basic. I think that this is specific to C64 Basic, not all of the 6502 basics that were produced or licensed from Microsoft. I think that this is a C64 or Commodore specific quirk shortcut. You don't need to, in most other languages you would have to say next C, so which counter or object or variable you are referring to, but Commodores are really smart and they can figure it out. So it is optional. It's not that you don't need, it's just that you shouldn't put it in there. Like if we put 30 next C, it will still do it. Oops. It's just optional, and I think that there's a whole lot of things, and I'll get to some later on, which I think were made optional because C64 Basic lines, code lines, so one of these code lines has got an 80 character limit, so which basically makes it 2 screen lines long, as we've covered in previous episodes. So there are a whole lot of things that I think are just shortcuts, so that you can pack as much code as you can onto a single code line. Now I was going to talk about steps, so we can change this, so we can say step 2, for example. So what we're saying is now let's count from 1 to 10, but in steps of 2. Alright, so if we run that now, you'll see we started at 1, and then it incremented the count by 2, so we went to 3, and then ran the code, did a next. Again, it basically is doing a check. Are we under 10? Or 10 less than or equal to 10? So it increments 2 each time. If this was 2 to 10, we would get them in still in increments of 2, but you'll see where it's starting now. And in fact, we can start it even at 0, so we can eke another line out of it. So you'll see this was 2, 4, 6, 8, 10, so we've got 5 lines of output, and this one here we've got 6 lines of output. So that is very interesting. Yep. I guess just a point on this next, with the variable being optional, if you nest next loops or for loops, it'll still figure it out, unless you do something really odd. I've never encountered it. It always just figures it out. So this, we're going to go to if statements now. So this is a little bit more in depth, and we need a little bit more background. So the basic we've got here, we set a variable b equals 3. If b is greater than or equal to 3, then print 3 or more. Now we will get into the different relational operators, which are these here. So the greater than or equals is a relational operator, which is different to that because that's an assignment operator. So we're assigning that, but we're checking the relationship or the relation between b and the number 3. So those are called relational operators. Maybe TMI. So if we got b equals 3, if b is greater than or equal to 3, then print 3 or more. Run that. Syntax error in 20. Wow. Probably helps if I put a number there, eh? So the Vice emulates the original key presses of the C64, so if you type too fast, it doesn't do it. It doesn't catch up. So we've got 3 or more. If we go 10b equals lots more than 3, and we run that, we still get 3 or more. 10b equals 1 or 2, run it, we get nothing. So that's nice and simple. So we can go if b equals 3, we're not gonna, do we change all the code? Equals 3. Wasn't that the name of a YouTube channel of a guy years ago? Is he still around? So we run it, nothing happens. 10b equals 3. We run it, it equals 3. So if we change that to 30, we're not going to get any output. So that is the basics of how the if statement works. If, and it does a check. If the check is true, then it will print this stuff here. Now, there is no else, and I've given you this infographic which I hope will help us. There is no else, only then. So most basic dialects will allow you to say if b equals 3, then print blah blah blah, else print something else. So in the case of this program, if we could do an else, then we would have something like else print doesn't equal 3. Instead, we get nothing, which is great. You can work around it with various things. So one thing to note about then, am I getting off my script? Yeah, there we go. Then we'll read all the statements until the end of the line. So we could actually say then print equals 3 colon print still 3 colon print banana. Fine. Right. And then if we went 10, so how's our code looking? So b is equal to 3. So if we run that, you'll see it prints out all of those things on that line. But if b is not equal to 3, it hasn't run any of them. So you can you can build up a bunch of things that it can do. You tend to have to, in practice, you might want to do a whole lot of things, so you might end up saying then go to somewhere else or GOSUB something, or do a GOSUB and then a GOTO. For example, if we wanted to, let's look at our code again. So if we wanted to say 30, this is how we would effectively work around the lack of an else statement. So we could go doesn't equal 3. Right, but if you'll notice, when we run that, we at the moment it's fine because it hasn't matched. So this line didn't, so nothing after the then triggered because this didn't match. But if it does match, you'll find we get all of it, right? So it equals 3, still 3, banana, and then it just goes down to the next line. So what we tend to do is, let's say, we'll make another line and we'll say, we'll just make that the program end. But then on line 20, we'll edit that and we'll put a go to 40. So what we'll do is we'll skip any statements that make up what we would consider the else portion of code. So that might be 5 lines, 10 lines, whatever. And then we would say if it matches, do this, and then go to the code after the non-match code. I don't know if that makes sense, but we can see that running. So now we've got, so b is equal to 3. So if b equals 3, then it will print these print statements, and then it will go to 40, which is the end of our program. If it doesn't match, then it won't do any of these things. So it'll just go on to line 30. So it'll print doesn't equal 3 and then follow through and go to the rest of the program. Alright, so b equals 3. So we get those and we do not, it now skips line 30. If we go b equals 4 and we rerun it, we'll just get doesn't equal 3. So that's how we work around the lack of an else command or statement, however you want to call it. Yeah. So here we go. This is a bit more in depth now. As we've seen, we did a GOTO here at the end, but we did a whole lot of prints. There are some shortcuts for GOTO. Like for example, if we let's do just a new quick program. B equals 3. We could swap it around. So the if b equals 3, then go to 40, right? 30 print not equal to 3, and then 40 will do the end. So if we run that, b is equal to 3, so it'll just fall through. Now we've got here then GOTO. Now some quirks of BASIC is that when doing this, both then and GOTO are separately optional. What do I mean by that? Well, if we've got here a condition, if a equals 10, or we've got b equals 3, then go to 100. All right, we've got that here, then go to 40. But we could also type then 100. We don't need the GOTO. Oops. All right. So maybe that would have been better if I had a something to print out. But you understand the logic of the code, right? We're not printing anything because we're skipping past it. So it is jumping to line 40. All right. Alternatively, we can just use GOTO, and we don't need the then. So it's doing the exact same thing. So all of these are the same result, and I've got perhaps these were done to help, another reason to help offset the 80 character line limit. So that code, as if we look at things like the way Commodore 64's command abbreviations work, question mark is an abbreviation for print. L shift I. Now I'll go into, if you were doing this on a normal C64, you would see L and you would press shift I and you would get that funny curl symbol is the equivalent of list. Right, so I could type in list, that would list my program, or I could go L shift I, that would also. So then, the command then has a shortcut of T shift H. If we were in lowercase, it would look like that, which is why in normal ASCII I've got it written like that. So line 20, for byte saving reasons, because we're working with a computer with only 64 kilobytes, in total, we could shorten it to 20 if b equals 3, then 40. Right, and you'll see that this, when we list the program, it'll look longer because it will expand those abbreviations, but we've been able to store those tokens in the basic memory in a much shorter form, so we've actually saved 2 bytes, I think, plus the lack of spaces, we've saved a few more bytes. Oops. Right, so it's expanded the then, but it hasn't expanded the spaces. It's given us a space here, even though we didn't type it, but it's a feature. Again, the listing feature. So this has managed to store the code in fewer bytes than it did there. And that might matter for larger programs. It might matter if you're doing one of those 10-line competitions, or it might matter if you're trying to obfuscate your code or your listing. I don't know, but yeah. So let's talk about relational operators. So we did the greater than or equal to before. We've done the equals. So it's the list on the left here is the list of relational operators. So you can check for equality, greater than, less than, greater than or equal to, less than or equal to, or not equal uses the greater than, less than, or less than, greater than together. Oops, buggerations. Wrong window. So I'm going to shift back into my lowercase because I like that. So if b is not equal to 3, then we're going to go to 40, and then 30 is, we'll change our code quickly here, right? So if b is not equal to 3, then we're going to quit, otherwise it'll print equal to 3. Great, isn't it? So we didn't jump ahead, we printed that because b was equal to 3. It should be noted that text and numbers can use these operators, so you can this I think I went over this in a previous episode when I was talking about strings, and maybe that'll warrant an episode on its own, given that I am at 28 minutes and I've still got a little bit to go. But just know that you can do comparison on strings using these, not just numbers. So we've also got logical operators, and, not, and or. Exclusive or is possible, but there isn't a direct command statement in basic version 2. They introduced it in basic version 7, which is on the C128s, but before that the Commodore 64s, it's possible to do it, but it uses the wait statement. I don't know why. You've got the wait statement is a weird statement, which is it waits for a memory address to have a value before it continues in your code, but you can use it to do an exclusive or. But if you do that, it means you've got to poke your data. So if you had b equals 3, you couldn't do an exclusive or on it until you poked that into a memory address, and then you would run the wait statement on that memory address, and that's forget about it. We're not going to go into that. That is definitely worthy of another video, but I might not make that because I value my brain. So, and, not, or. Now these logical operators matter depending on the context. Alright, I'm just going to do a new on here and clear my screen. So you can use them as bitwise operators. So you can A equals 64 or 32 will do a bitwise OR, and this is going to be weird using these words there. Or depending on the context, if we're using them as in an if statement, then we can say if this or that, then do that. So we've got bitwise operations, and we can use them as comparison operations. I don't know what you call those. Now, it does raise the point that to do it in an if statement, you have to, each of the condition has to be repeated in full. So if A is greater than or equal to 30, or A is less than or equal to 100, right? So you can't just go if A is greater than 30 or less than or equal to 100, or you can't go if it is greater than 30 or 100, because if you do that, it will just do a bitwise OR. So what does the bitwise ORing mean? I'm going to have this table here too. Hopefully this will all fit on the screen. So if we did A equals 64 or 32, we're going to print A, and we get 96. I guess a binary is a little bit out of the scope of this, but I'll try and do a quick primer of how that works. So each 8-bit number has got 8 bits. The bits are ones or zeros. So as each bit gets added together effectively when used in a decimal. So if we had A equals 64, if that was purely in binary, there would be a 1 here and the rest would all be zeros. The 32, the 1 would be here and the rest would all be zeros. So the reason the OR statement produced 96 was because it ORed those two numbers. So and I don't have a binary truth table, but effectively if it's checking for a truth, right? If we're using OR, one or the other is 1, then the result will be 1. If we were to do an AND, then the result would actually be 0 in this case, because 1 and the next number doesn't have a bit here, so the result is 0. I'll get to that in a bit. So we're doing with the OR. So OR 64, 32, 0, 1, 0 or 1, we get a 1. These are 0 or 0, and these are the rest of them are going to be 0. So what the result of this OR command or mathematical equation is it is saying, okay, well the result will be this number here, which when BASIC interprets that as an integer, as a number, as a decimal number, it'll get those 8 bits and it'll add effectively these values together, right? Sort of say, okay, well, 128, 0, 64, 1, 32, 1. So it'll say 64 plus 32 is equal to 96. The rest of the bits are 0. So the significant bits, the ones that equal 1, will get counted up, and that is how we get that result. So in binary, the 0000001 is equal to 1. If we want a number equaling 2, we will have the rest will be zeros. So that's how we do it. That's how we count. So if we want to count to 3, we will flip bits 0 and 1. These are the values, and this is bit 0. They tend to consider this is bit 0, this is bit 1, this is bit 2, this is bit 3, this is bit 4, and so on, bit 7. So if you flipped all of those bits to 1, you would have a number equaling 255. So the same thing when we go AND. Let's go A equals 64 and 64. Print A. What? Need a colon in there, otherwise bananas will happen. So we've got 64, and the reason for that is because as we clear this stuff out here, the first number had a 64, the second number had a 64, and it didn't AND. If the first number and the second number have a 1 in that bit position, then the result will be a 1. If we had a 0 and a 1, it would be a 0. And we can prove that by going A equals 64 and 128. Print A. A. So the result is 0. And the result was 0 because the first number had that bit set. The second number had that bit set. And it went, okay, I'm going to AND those bits. 0 and 1. 1 and 0. So they both got to be set for the result to be 1. Which is why when they were both 64, that bit got set. I hope that kind of makes some sort of sense. I'm not very good at explaining that, I don't think, but give it a try and go over these. Look up binary truth tables. I'll call that binary truth tables. So if you look that up, you'll be able to get a better idea by looking at the table and saying, or using them as a reference. Maybe at this stage you won't be using them. I guess our focus for this one is to use them in if statements, and so when you're doing that, as long as you make sure that you are building your statement up correctly, you're putting both of your checks written out in full, then it will be a comparison, not a bitwise operation. And I did do this here, which if we've got A, just to show another example of the difference between ORing and ANDing. If A is greater than or equal to 30, or A is less than or equal to 100, then print A is any number, and I'll explain that in a sec. But if we go, if A is greater than or equal to 30 and A is less than or equal to 100, then A is between 30 and 100. Right? So A is equal to 50. So both of those have triggered. Right? And the reason for that is because if A is greater than or equal to 30, yep, that one matched. Or A is less than or equal to 100, it was 50, so yep, that one also matched. Then A is effectively any number, because you've basically said if it's greater than or equal to 30, then I'm going to trigger. So from 30 through to, infinity will trigger. Or if A is less than or equal to 100, so if it is 100 or less than, even a negative number, that will trigger. So effectively this will always trigger. If we wanted to ensure that it was between a range, we would have to use AND, because we want to say I only want the stuff after the then. I only want it to trigger this then statement if both of these are true. Right, so this is one or the other is true, and this is both are true. So that takes us back to our binary here, where when we had both numbers being a 64, both were true, so that triggered. But when we had only one or the other were true, neither triggered, which is why when we did the A equals 64 and 128, we got nothing. We can get it to, actually, however, I guess another way of doing just to show you let's go A equals 96 and 64. Alright, so if we look at that, so if we say 96, we'll have a 1 here and a 1 here. 64 plus 32 is equal to 96. 64 will have a 1 here and nothing else. So the result we should get by doing this print should be a 64, because it will go through each bit and say, okay, well, that and that are true, so I'll mark that as that'll trigger 32, and the next, so the bit this bit will be set on 96, but it won't be set in the number 64, so that won't trigger. So the output of A equals 96 and 64 should be 64. So I hope that made a little bit more sense. I'm going to minimize all this stuff now. Where are we? Wow, the statements. Did I cover all of that? Logic operators, binary. The script thing sometimes works, doesn't it? That was if statements. Crazy. Complicated. But there we go. You thought this was going to be easy, didn't you? On is a relatively easy one, so this should be quick. This is a statement that uses an index that starts at 1. So it basically it's kind of like an if statement. Well, it's more like a case statement if you've encountered those in other languages. I wonder if I should have learned how to Can I do an edit paste in here? Oh yes, no, syntax error. Bar weasels. What? Come on, what did you do? Maybe it's the tabs that it didn't like. Well, it saved me typing in one line. Super. So on I, GOSUB. Now this can be used with GOSUBs or GOTOs. Right? I'm going to stick with GOSUBs for now, but just so you know, oops, bollocks. Change window. That can be GOSUB or GOTO. 100, 200, 300. Right? So we're saying on the, depending on the value of I, we're going to go to one of the, or go to one of those subroutines. I'll explain a bit more in a sec. Right? So 35, we'll just do an end because we, as you know, we don't want to run through those again later on. So we will print I, and I'll just say, just to show that this is the GOSUB 100 section of code. So you can see this is like normal GOSUBs, right? Print I to 10, and we'll do a return 300 GOSUB 300 310 will be a return. Okay, what do we got? So we've got a for loop iterating and taking our count from 1 to 3. Depending on the value of I, it's going to go to, or GOSUB, it's making it tricky, it's going to go to one of these subroutines. But it starts at an index of 1. So its usefulness kind of seems limited at the outset. But, you know, if you had larger numbers, you could do some kind of a mathematical thing to figure out what, you know, or reduce those numbers to indexes of a 1 base. So let's run that. So what we've got here is we go I equals 1 to 3, and it'll do a GOSUB. So when I equals 1, it'll go to that first index. So it'll GOSUB 100. It'll print that, and then it will return. And it will return to the next statement, which is next. So then it'll say I equals 2, and for on I, when that index matches 2, it'll go to the second element. So that's GOSUB 200. It'll run to that subroutine, run that code, and return. Do a next, I equals 3. It'll go to the third index, or the third item. It'll do a GOSUB 300, a return, and then the program will end. Okay, so we can see that shows our value of I, 1 to 3. Now, to show that it only triggers on those indexes, if we change it from 0 to 3, so we're actually iterating through the code 4 times, we still only get the 1, 2, 3. Oops, I lost my code. That's 10. So if we were to change that to 5 to 9, you'll see that, let's go list to 20. You'll see it knows it's got 3 indexes. So it is not going to say the first item is going to go there. It is literally saying if I equals 1, GOSUB 100. If I equals 2, GOSUB 200. If I equals 3, GOSUB 300. So these will never even trigger. as you can see, that none of them triggered. So you don't see it used a lot for that reason. But you know, if you can modify your code or figure out a way to set up a one-based index and then use that for your on statement, then it can be useful. I mean, it certainly saves you having to type out if I equals 1, then go sub 100. If I equals 2, then go sub 200. It's just a shorthand for that, and it is of limited use, but it is another tool in your tool belt, as it were. So I think that is the end of the show. I do believe we've covered everything. We did the for, we did the if. This is the most important thing to remember. There is no else, only then. I think that's us. Thanks for watching. I'm glad I didn't sneezy and snotty all throughout this video. I've been feeling under the weather lately, as the weather has been changing here. How long have I been rambling for? Almost an hour. I'm gone. Thanks for watching. Thanks for your support. Please leave comments, questions, thoughts down below. I'll try and answer them. If I haven't explained anything properly, let me know. I'll try and explain it a little bit better. And yeah, see you in the next video.